Welcome to this web lecture about command languages. Unlike natural languages such as English and Dutch, a command language is a language that we design. It's completely artificial. Therefore, we can achieve goals that natural language does not reach, such as precision. We know precisely what each command means. And the commands can be very compact. We don't need to be very verbose in our expressions. Commands are easy to write and, depending on the choice of words, also read. And you can quickly learn a small set of commands, especially if they use meaningful words. Simplicity in command languages reduces errors that the users will make. We can also make command languages easy to remember by using words that people know from their natural language. If the command to print a document is called print, we can easily remember that it does that. And to copy a document, if it's called copy, again, we can remember that. There is always a compromise between having a very rich command language that offers a lot of functionality, but that is hard to learn and remember, and a very simple language that doesn't have commands for everything we want to do. The high-level goals of command language design are a correspondence between reality and the notation, such as with the print command, convenience in carrying out the manipulations that are relevant. So for everything we want to do, we need to have a suitable command, and we don't want to have to use a series of commands to achieve a simple task. There should be compatibility with existing notations, with existing natural language also, and flexibility to accommodate novice and expert users. This is often achieved by using options. So the command does the most sensible thing for most cases, but sometimes you want it to do something slightly different, and there can be options to achieve that. The expressiveness of a command language can encourage people to be creative in how to combine the effect of different commands. Languages that we design can have a visual appeal. This typically happens when we beautify a program or a series of commands using white space. For that to work, the language design must be such that the white space is meaningless, that it only functions to beautify the layout and doesn't change the behavior of the commands. To support the user's task, we need to start by creating a list of the task actions that need to be performed and the types of objects that can be used. Then we abstract this list into interface actions, into commands, right? And the different types of objects, we also categorize them. Some things may be files, some may be directories, for instance, some may be devices. We choose a common low-level interface syntax. For instance, commands that are words, then separated by a space from possible options and arguments. And all options starting with, say, a minus sign. Right? That makes it clear, right, for all the commands how to actually specify these options and arguments. We create a table of the expected use frequency. Very common commands must be learned by everyone and also remembered. Commands that are rarely used need not be all that easy, and especially commands that have dangerous consequences can have, for instance, a longer name that is more work to type, for instance, shutdown, than a command that you execute a lot, like print and copy. We have to also determine how important the commands are for each of the user communities, so that we distinguish the beginners from the experts. where possible, we have to also ensure that destructive actions can be reversed. And this, in many command languages, has not been taken into account sufficiently. Especially command languages for computers, like a shell, a command window in Windows. The commands you execute there, they often have no undo. But commands also used in, for instance, a text editor, the commands in a text editor are also a command language, there often these operations do have an undo. We should also prepare error messages for all the possible error conditions that can happen using the command language. And again, shortcuts for expert users can also be applicable in command languages, specifically by using macros to create new commands and by combining a number of existing commands and then binding them to a single new name. There are several strategies for organizing commands. It helps if we have one unifying concept or metaphor so that it is easier to learn and remember how the command language works, because it all works in the same way. We can have metaphors that are derived from the task domain, not from the machine domain. And keep the command set simple to start with. At least the command set that most users have to learn. One command per task works generally better than having one command for 5 tasks, right, and having options to make this one command do the 5 different things. We'll see with some examples that in fact, in reality, we often have a single command that through options is used for 5 different tasks. An example of a simple command set is found, for instance, in the VI editor in the Unix system. It's a screen editor with single letter commands to move the cursor up and down, to delete a character or a word, a very simple command set. For more complex operations, we can have commands plus the arguments. The commands with their arguments are easy to learn if we have simple commands like copy and a convention that says, well, if we say copy file A, comma file B, it means file A is copied to the name of file B. Or delete file A, the meaning is very clear. We can also opt to have the options specify the role of the different arguments. So copy copies from to something, right? And so we say from is this file and the to is something else. It's more verbose. It may be harder to remember, but it's much easier to read. There can never be a confusion. Copy file A to file B. Well, copy file A, file B. What does it do? Does it copy file A to file B, or does it copy file B to file A? Such confusion exists, for instance, in the Unix system with some of the commands. Commands may have options like print/3 to say, oh, printed 3 times, 3, HQ, printed 3 times on the printer that is named HQ. And different possibilities for syntax there, but such that for most users, they don't have to specify that to get just one printout on their standard printer. They just have to know that the command is print. Error rates and also the time and the need for training increases with the number of possible options. This is true when the command set is richer, and it's also true when we have fewer commands but lots of options. Consistency in the structure and syntax helps with the learning and problem solving and memory. Unfortunately, there are many cases where command languages are inconsistent. Here we see a few Unix commands. cat A, B, for instance, concatenates the files A and B and the output goes to what is called standard output. So A and B here are both inputs for this command. And if we say move AB, it actually means that the file A, maybe the file A is renamed into file B. But if B happens to be a directory that already exists, then move AB keeps the name A, but moves the file A into the directory B. So depending on what A and B are, the command starts doing something differently. This is highly inconsistent, this is hard to learn, and with commands like move, and also the other one, the link AB, and link -s for symbolic links AB, people make mistakes all the time because the command has so many different meanings depending on this option, used yes or no, and what A and B are. Here we see a table to illustrate some experimental research output. Users were confronted with a symbolic representation versus a keyword representation. What was found, and which may be counterintuitive, is that the more verbose representation in the keyword editor is not only better for novice users, but also for experienced users. The error rates go down for everyone. So it's not true that expert users benefit from a terse, cryptic, but very short command language. No, making it more verbose helps everyone. So we have to choose meaningful names with consistency and a good strategy for constructing abbreviations. Commands have to be either specific or general. Here we again see a table with examples of words that are good choices or bad choices. Like if we use infrequent but very nicely discriminating words, they may be easy to remember. Insert versus delete. Or frequent words like add and remove. They're easy to remember. But there are choices that are actually bad choices because maybe the words are nonsense, kak, mik, or they may be somewhat confusing. Alter versus correct. It's not clear what the difference between those is. The names and abbreviations are often the result of people reaching consensus. Someone invents an abbreviation, other people like it, they start also using it, and before you know it, the whole world knows that LOL means laughing out loud, and CU means see you, and we see too good to be true. You all recognize these. It doesn't take the whole world to agree. Some of these abbreviations are also topic specific. You may not know what SOOC means, but if you're into photography, you know that it is straight out of camera, using the first letter of each of the words. There are generally 6 strategies that are commonly used to come up with abbreviations. Simple truncation uses first, perhaps second or third letter of each command. We see examples in the VI editor, W for write, Q for quit, all single letter commands. We also see this, for instance, in many airport codes. AMS for Amsterdam, BRU for Brussels. We can have vowel drop, where we see the consonants of the words like list, move, and copy, but only the first 2 consonants are kept. Sometimes we can use the first and the last letter of a word, since they are often highly visible and people can make sense even out of whole sentences when all the words are reduced to the first and the last letter. Sometimes the first letter of each word in a whole phrase. Print working directory line printer. This is also used for some airport codes like the John F. Kennedy, JFK Airport in New York. There are also standard abbreviations that come from other contexts. Quantity, QTI, X-talk, where the X is actually the cross for crosstalk. And sometimes the abbreviation itself doesn't make sense, but we only look at how it sounds. The letter C doesn't appear in CU, but the letters C and U together, they just sound like CU. Now, how should we use these 6 strategies? The guideline is to, where possible, have one primary rule that you use for everything. That doesn't always work. When it doesn't, you need a secondary rule for the items where there would be a conflict from the primary rule. Hopefully, you won't need a third rule. The user should be familiar with the rule so that when they forget what a command is called, they can reinvent it by using the primary rule on a natural language word that they know. Truncation is a simple rule that users understand. It's very easy for users to recognize that AMS, right, is the code for Amsterdam, or that LP is line printer, or that MV is move, where it's not this truncation, but it's another simple rule. Fixed length abbreviations are preferred. Airport codes, all 3 letters. Unix commands, the most common ones are 2 letters. Simple standard agreement. Never incorporate grammar. Words do not end on ing, ed, and s in any command language. Do not use abbreviation in the messages that the computer generates. Abbreviations are for the commands you give to the computer and not for the responses the computer gives back. So in your final assignment, we don't want to hear computers speak in the messages that your program is going to give to the end user. Thank you for participating.